Hello everybody, welcome for the presentation. So this is our fourth video in the fourth module of Ktu Ce202 Structural Analysis 1, Moving Load and Influence Lines. So recalling what we have studied earlier. So in the first video we saw the basics of influence lines and moving loads and the derivation for a simply supported beam when a unit load is moving from left to right. So we saw how to draw the influence line for reactions, shear force and bending moments. In the second video, we saw an example when a concentrated load is moving from left to right. In our third video, we saw another example for a simply supported beam when more than one concentrated load and an UDL shorter than the span moves from left to right. So in this fourth video, we will see another example for more than one concentrated load and UDL shorter than the span for a simply supported beam moving from left to right. This is our given problem. 4 equal loads of 80 kN each is spaced equally at 2 meter apart, followed by an UDL of 60 kN per meter and is running at a distance of 2 meter from the last 80 kN load of total 20 meter span from right to left. Using influence lines, calculate shear force and bending moment at a section 8 meter from the left hand side when the leading 80 kN load is 5 meter from the supports. So listen, the first condition given for you is the supports are simply supported. Now the loading conditions are 4 equal loads of 80 kN each is equally spaced at 2 meter apart. So now we will draw 4 numbers of 80 kN loads placed at a distance of 2 meters apart. Okay, so 80 kN loads, 4 numbers of 80 kN loads, the distance between the loads are 2 meter. So now next it is given these loads, these 80 kN loads are followed by an UDL of 60 kN per meter. So we have a 60 kN per meter UDL load and is running at a distance of 2 meter from the last 80 kN load. So from this 80 kN, from 2 meter from this last 80 kN, we have an UDL of 60 kN per meter. But the total length of this UDL is not given in the problem. So we will draw that. So we have 60 kN per meter from 2 meters from 80 kN. We don't know the total length of this 60 kN per meter. Now the next condition given is the total span length is 20 meter. Total span length is 20 meter and the load is traveling from right to left. So total span length is 20 meter. We will draw the span now. So we have a 20 meter span. So the next condition given is using influence line, calculate the shear force and bending moment at a section 8 meter from the left hand side when the leading 80 kN is 5 meter from the support. So the leading 80 kN load, leading means the first load. So first load in the given diagram, because the given set of forces, the given set of loads are moving from right to left. So when it is moving from right to left, the first load, that is the leading load, is the first 80 kN that is the load near the support A. That is your leading load. Because the condition given is the loads are moving from right to left, right to left. So, the first 80 kilonewton load which you see in the diagram is your leading load. Now, see, the section is taken at a distance of 8 meter, and one more condition is given, the leading 80 kilonewton load is 5 meter from the support. So, first 80 kilonewton load is 5 meter from the support. Now, we can determine what is the length of this 60 kilonewton per meter, the length of the last UDL, uniformly distributed load. So, totally for the first 80 kilonewton it is 5. So, 5 plus 2 7, 7 plus 2 it is 9, 9 plus 2 11, 11 plus 2 13. Total length of the span is 20. So, therefore, the length of the UDL will be 20 minus 13, 7 meter. So, the UDL will be for a span of 7 meter, because the condition given is followed by an UDL of 60 kilonewton per meter and is running at a distance 2 meter from the last 80 kilonewton load. So, we do not know for how much length. So, we will assume. So, it is taken as from this last 80 kilonewton, from the distance of 2 meter, it will be continued till the end of the support. Now, this is our given problem. So, all the conditions are marked in the simply supported beam. Now, we are asked to find two things. One is the shear force at point C, or shear force at a distance of 8 meter from the support A, and bending moment at a distance of 8 meter from support A. So, the section C is taken at a distance of 8 meter from the support A. So, we know the influence line diagram for the shear force for a section is like this. From A to the section it is negative, and from the section to B it is positive. And the ordinates are, that is, the negative ordinate is x by L and the positive ordinate is L minus x by L. Okay. So, the negative ordinate is x by L and the positive ordinate is L minus x by L for the section. Now, see this x by L and L minus x by L, if we add, we should get 1. Always remember, while you are drawing the shear force diagram for a section, for a simply supported beam, our negative ordinate is x by L, the positive ordinate is L minus x by L, and when you add these both, you will be getting 1. Okay, so L minus x by L plus x by L, you will get the value as 1. We will get L by L, that is equal to 1. And we are substituting the value of x. So, x is 8 meter, so L is 20 meter. So, 20 minus 8 by L, we get 0.6, 8 by 20, we get 0.4. So, these are the maximum negative and positive ordinates for the influence line diagram for a section C. Now, we need to find the ordinates under the load. In order to find the magnitude of the shear force at C for the given loading condition, we need to find what are the ordinates under the load in the influence line diagram for the shear force. So, we are drawing the ordinates. First of all, we will draw the ordinates. Now, see, we know the maximum negative and maximum positive ordinate. We will use the similar triangle principles to find the ordinates, to find all the positive and all the negative ordinates. Okay, we are using similar triangle principles for every distance. So wherever the load, wherever there is a concentrated load and an UDL, we will find the ordinates. So the ordinates are found using similar triangle principles. So the values are, we will plot the values, we will mark the values at every ordinates so that it will be easy for us for finding the shear force. Now the magnitude of the shear force will be equal to the magnitude of the load multiplied by the corresponding ordinates in the influence line diagram. So shear force at C will be equal to the first load, that is 80 into minus 0.25, that is a negative ordinate, plus the second load 80 into minus 0.35, that is also a negative ordinate, so that it is taken as minus, plus 80 into 0.55 positive coordinate, plus 80 into 0.45, plus 60 into the area in the influence line diagram under the load. So it is a see, previous problem we saw the area under the load was a trapezium. Now the area under the load is a triangle, so we will take the area of a triangle. So 60 kilonewton per meter is the UDL. So 60 into the area under this UDL in the influence line diagram, that is a triangle, so half into base is 7 meter, height is 0.35, that is the ordinate. So we get the total shear force for the given loading condition at this section 8 meter from A is 105.5 kilonewton. Now we will go for how to find the bending moment. So same way for any given conditions of loads for a simply supported beam, we know the bending moment for the influence line diagram for the bending moment is like this. So both the section for both the parts we have positive ordinates, and the positive ordinate is x by L into L minus x. So by substituting the value for x is equal to 8 and L is equal to 20, we get 4.8. That is the ordinate is the maximum ordinate in the influence line diagram for the bending moment is 4.8. 4.8. Now we can draw the ordinates, and by using the similar triangle principles, we can find the values of the ordinates. So the ordinates under the loads are drawn. So we use similar triangle principles, find the values of the ordinates. So all are positive ordinates. Now the bending moment will be equal to the load multiplied by the ordinates. And for UDL, it is the load multiplied by the area under the load in the influence line diagram. So finally we get the bending moment at C for the given loading condition is 1804 kilonewton meter. Thank you. Hope you all understood this. So if you have doubts, you can comment on the comment section. Thank you.